Okay, so I decided to make number 39 in a different video. It's going to be along the same kind of question as 38 is, and we're using distinguishable permutations. So I don't want this previous video to go too long with just two questions. Okay, so we should already know what it means for distinguishable permutations. Let's read number 39. It says there are 10 gumballs left in a gumball machine. 4 are red, 4 and 6 are yellow. You put pennies in until you empty the machine. How many distinct orders of red and yellow gumballs can come out the machine? When it says distinct orders, that means order matters. Hence, we have a permutation. But when you look at gumballs, yellow and red specifically, there is no difference between yellow gumballs within the yellows, and there's no difference between red gumballs within the reds. Although red and yellow are distinct from each other, in their subgroups, they are considered the same because there is no difference in terms of the colors within each group. Hence, we have the organization of items that are distinct from each other but considered identical in the same subgroup. Distinguishable permutation. So for number 39, 39, we have a total of 10 gumballs. K sub 1 is going to be red. K sub 2 is going to be yellow. I believe that's how it's written. There are 4 red gumballs. And there are 6 yellow gumballs. Because we already established that we'll be using the distinguishable permutation formula, that is going to be 10 factorial divided by 4 factorial times 6 factorial. So 10 factorial, I'm not too sure what that is, but when we compute 4 factorial, we get 24 from the previous video. And 6 factorial, I know that's 720. 6 times 5 times 4 times 3 times 2 times 1. But when we do 10 factorial, go over to PRB, that gives us 3628800. So it looks like it's a number in the millions. 3,628,800. We write that last zero at the end. And we can divide that by, well, first, before we divide, let's multiply 24 times 720. So that equals to, actually, I'll go down here. 3,628,800 equals to 17,280. So I'm going to be lazy. I'm going to put 10 factorial because I don't feel like typing in that number. Divided by 17,280. And that equals to 210. Distinct orders. And there you go. All right, that is it for number 39. Hopefully that made sense. You can go back to 38 if you need to once again recall the concept of a distinguishable permutation. And I'll catch you in the next video. Take care.